topics that they want to talk about in the future, definitely let us know, and we'll get stuff scheduled. I'm happy to host too. But thanks for Trility for volunteering and kind of help coordinating and kind of poking at us to get going. So thank you for that. And we'll just get started. Floor is yours.
All right, let's get rolling. We'll just let's see, here we go. So we'll talk about, we'll just kind of cover a real quick agenda here. So who we are, or who are we, who we are, problem statement, some of the tools we're going to talk about. We've got some pretty pictures to go over with an account and a network diagram, and then we're going to kind of cover the Terraform solution at a real high level. And if we've got some time towards the end, would absolutely love to get some input and some feedback from folks. So if you have questions, you can certainly ask Nate or I at any point during the conversation. I think Levis is going to be keeping an eye on the Zoom chat, and I'm going to probably ramble on about nothing for way longer than I should. So let's get into it. So who are we? So I'm Eric Gerling. I'm a senior DevOps architect with Trility Consulting. Lots of words on the screen, but basically been doing DevOps since before it was called DevOps, and actually probably doing what's now called GitOps. So I'm sure in another year or two, what I do gets another flashy name. We'll just have to wait and see. Do a lot of stuff in some different clouds. The vast majority of my experience is with AWS. I've done a little bit of stuff in Google, done a little bit of stuff in Azure. But again, the lion's share of the experience that I've got is in Amazon. And for the most part, I do everything but the pretty pictures is kind of what I call it. So I do a lot of I've kind of stayed away from from the JavaScript, CSS. Insert name of a cool framework here. So I tend to stick more to the back end stuff. So do a lot of infrastructure, a lot of back end applications, and putting some of those stacks together. And that's generally where my focus is at. So, and then we have Mr. Levis.
Hi guys, I'm Nate Levis with Trility as well. I'm a solutions architect here. Again, a little blurb here, just about a few things. Like I said, just been focusing on, came up as a dev, been doing DevOps as of late, last few years. Always just trying to do incremental progress across everything. I like Agile, but not big A Agile, not what it's become. I don't even try to say Agile anymore. I just do Agile things, and then just keep on going because it's been turned into so much. But it's still a lot of good stuff there, still a lot of good principles. So try to be pragmatic and open to everything. Eric's got more certs and stuff than me in different areas, but I do have my solutions architect. So that's kind of sums me. And so yeah, I'm here on Trility and just helping with the sales sides of things. And so still like to say I'm technical. I'll just be kind of asking some questions here and there if people aren't speaking up. So thanks everyone for joining. And again, we would encourage, please, if you think you can save questions in if you want, but actually at the same time too, just post in the chat or speak up yourself, and we'll make this interactive. So.
All right. Thank you, Nate. So moving on. So we're going to talk about the problem statement. So one of the things that we definitely when we're either working with a new client or we're working with a new set of individuals or just really having a conversation just amongst ourselves is we like to try to understand what the problem statement is. And so that's kind of how this presentation is sort of structured. Is we're going to start with the problem statement. We're going to kind of talk about some of these individual problems or issues that we want to try and attack as we go through this individually to really sort of ground this into something that matters. So this is based on an implementation that we did for a client, and so this is this is all code that has that's run in production and has been running in production actually for almost a year. with some minor tweaks and modifications along the way, as most code does. So this isn't pie in the sky. This is real problem statements that we had to come up with solutions for, and then some very high level of solutions. So as we, how do I manage multiple AWS accounts, resources spread across multiple regions, and do that without completely pulling my hair out? Which I don't have my camera on, but I'm completely bald, so hair has been long since goodbye. Some of the core tenets of what we want to try to do, those attributes are going to be infrastructure as code. So we want everything checked into Git. We want that single source of truth for AWS accounts. We want to be able to deploy things into new regions very, very quickly, and then VPN access into these networks, and be able to access all of these dynamically created environments in multiple regions very quickly, very efficiently, without having to do a lot of work. The end goal is, development teams, infrastructure teams can operate independently and be able to do the things that they need to be able to do to be successful. And so that's really what really want to do. But the problem is, how do I manage all of that? How do I put all of that together in a cost-effective way? So to kind of break down that problem statement, there's a couple of big bullet points. So we're going to talk about infrastructure as code real quick. I'm sure a lot of you are familiar with this already. A couple of years ago, this used to be kind of a new thing. Now it is pretty much the only thing. And so it's really all things in code all the time for everything. Generally, when I approach a solution, when I approach a new product or a project, I want to make sure that I can manage all of those things in code all the time, and whether that's writing bash scripts or Python scripts, or using something like Terraform or CloudFormation, being able to put all that stuff into code and check that into Git just gives us a level of accountability and a level of reproducibility for everything that we do. It's there, it's available, and it's absolutely, in my opinion, it's core component to do anything really in a cloud environment at this day and age. The choice that we prefer, though we certainly do other things, is Terraform. So a couple of the big, there's lots of reasons and there's lots of conversation around Terraform, CloudFormation, CDK, Resource Manager. There's lots of different tools that are out there. The big ones for me, the big things that I really, really love about Terraform, one is state file management. So this one certainly can generate a lot of debate with a lot of different people. I prefer to have the state files. I prefer to manage those state files. I prefer to really be able to do anything and everything that I would ever want to do with a particular state file for my AWS accounts. And so being able to have that information, being able to manage that information, understand it, store it, and manipulate it if I need to, is definitely very powerful to me. I cut my teeth in the Amazon world in CloudFormation, and the number of times that I will bump against something and just couldn't quite get to exactly what I needed to do. Once I made that transition over to Terraform, I really never encountered that, ever encountered that again. And then another big one for me is importing of resources. And so that's something into state files. And it's sort of a branch off of state file management, but not every time are you going to be able to walk into an environment that's a clean account, right? Generally, people have got stuff in accounts. People are working in those accounts. People have services that are launched and running and very active. And so being able to import those resources into a state file and just be able to start managing those things in an infrastructure as code mentality or process is extremely critical. And so that's something that I spend a lot of time doing myself, is as I get into new environments, as I work with new environments, is making sure that I can import those things into Terraform. So it's I don't want a system that's like, okay, here's quote legacy that we do all this stuff by hand, and then here's the new fancy that we do everything infrastructure as code. As we all know, legacy doesn't generally go away, right? We talk about sunsetting it, and then it's 12 months, and then it's 18 months, and then it's 2 years, and it's 3 years, and it just never seems to die. And so being able to take those resources and import them into state files and import them into the infrastructure's code process and mentality is super critical, because then it's less of that legacy, and it's more of, okay, we're now doing things in code, and we can now transition some of those things in a pipeline driven way and do that the way we want. Rapid deployment into new regions. So obviously, every cloud provider's got whether they're regions or we'll stick with the region, but different locations to be able to put stuff. Amazon has done a lot in the last couple of years, making regions, inter-region applications and services much easier to manage. And so being able to take advantage of those things and to be able to either do active or passive, even having warm regions is super critical. And being able to utilize a lot of those tools and a lot of that infrastructure that Amazon has sort of put together to be able to really take advantage of some of that stuff as application scale and as usage scales is definitely critical. Then you also have regulatory compliance in some of those regions, right? So if we start looking at, we're building an application in the US. Now we want to talk about going to Europe. Okay, that's, we've opened a whole new can of worms from a regulatory compliance perspective. How do we manage infrastructure in both places, make sure that data is stored appropriately in both places, but not, again, have to end up writing 2 different systems or 3 or 4 or 5 different systems? How can we manage it all as a single system or a single set of code? And security is incredibly important, and it is a real critical thing for us to be able to do. And we have to keep that in constant top of mind. Single source of truth for our AWS accounts. So AWS accounts are not static. They absolutely live and breathe. And once you have one account, pretty soon you want another account, and then pretty soon you have 30 accounts. That's just kind of that's sort of the way it goes. And so being able to manage all of the environments, manage all of the code, and do that as a single source of truth to those accounts is super critical. And to make that a process is not arduous. And so when new business unit or existing business unit comes in and they say, hey, we need this, and here are the reasons why, and we go, cool, no problem. Here's your new account. We've laid out all of the appropriate security and regulatory compliance. Your VPNs will automatically hook up or your VPCs will automatically hook up to your VPN. All of that stuff is good. Being able to do that out of a single source of truth or out of that single set of code is very important. And then VPN access. Again, we talked about this. There's lots of different ways to do this with this particular solution. The customer did not have a VPN solution in place, and so we had to come up with a VPN access into these things. And so ended up using AWS Client VPN, which is a little expensive, but certainly does a trick and put together a process for us to be able to support dynamic deployment environments, and then allow various levels of access for various levels of individuals and be able to put that together. So moving on. So some of the tools. So we'll talk a little bit about Terraform, CI/CD orchestration, and then some different AWS services that we utilize in this particular solution to solve some of these problems. Terraform. So we talked a little bit about it already, but there's a tool for building, changing, and versioning infrastructure safely and efficiently. Cool. It's my opinion. It's one of the better tools that's out there. It certainly had some growing pains, but has really matured, over the last probably the last 2 to 3 years, and is really a very powerful tool. The execution plan. So when you're doing what I call the sort of the Terraform dance, where you're doing your init, your plan, and your ply, getting that plan, being able to pull that information in and be able to do detailed analysis of what it's going to do to your environments. Even that's coming out here shortly, they're providing even more ability to sort of break that stuff down and do some more programmatic evaluation of those plans. So that's very exciting, and to be able to see in a very detailed level what it's going to do before it does it. And I know Terraform's not the only tool that does that, but it was certainly one that sort of broke the mold there, and everybody's sort of playing catch up to do the same thing. And it's automated. It's very fast. It's very easy to be able to write your stuff, test it, validate, see if it's working, not working, tear it down, destroy, and go through that iterative process very, very quickly in a development environment, and that makes that very, very unique. So, Nate, do you have any experiences with Terraform like to share with the group?
No, I mean, I know it's just, Terraform kind of affords you more, some more kind of variability, and you kind of spoke to a little bit the conditional programming aspect of it, looping and things like that, that make it a little better. And then, of course, I think one thing that people always get, I think one thing that kind of shoots down Terraform sometimes is people, you say, well, you should use Terraform because then you can use, any provider. And people say, we're never going to switch providers, and don't gold plate and all these sort of things, and don't build for something you don't need and all of this. But it also, I mean, it gives you the option. And I think a lot of companies, I don't, if you're doing a lot of cloud stuff, but you might do your Active Directory might work better in Azure, or I know another big client around town kind of let their cloud was kind of pick your own poison for a while. And so consequently, they ended up with different cloud providers, large enterprise company where things got a lot of hand, but they probably want to look at Terraform, even though I think they are considering more some CDK stuff. They want to look more for Terraform because it does give you that option. So I don't know. Again, I think it gets shot down a lot where it's like, oh, we're never going to need to change and things like that. But I think as you show here later on, you can leverage other pieces of the cloud, other areas that you didn't think about because there's providers for almost all things, and it just gives you more, more flexibility down the road.
So we did have a question in the chat. How do you work around some of the limitations in Terraform supporting new features like express step functions? That's a great question. Hold on. Sorry. Ooh, my bad. Anyway, great question. And that used to be an absolute significant issue with Terraform. And it still is to this day, though generally not nearly as often. So a couple of ways that we've managed that. One way that we've managed that is we'll intermix Terraform and CloudFormation. And so we'll write up some CloudFormation templates if that's what we need to do to be able to support that particular process, and then we'll wrap that inside of Terraform so we can still deploy that stuff through our existing pipelines. So that's been done. Or in a lot of ways, and this is not necessarily just a Terraform thing, but this will happen for other products as well. If we're not able to utilize it in the method that we would like to use it in, generally what we'll do is we'll sort of have that conversation around, is this tool critically or super valuable for us to be able to use right now, right at this moment? What problem are we going to solve with this particular thing? And as a larger organization or a larger group, we'll have that conversation. And if the answer is yes, then we find a way. And if the answer is no, what we'll do is we'll sort of set that on the back burner as something to watch or something to kind of keep track of. So it just sort of depends on what it is. Generally, like I said, if it's in an Amazon environment and we believe it's a critical thing or a critical need, we'll look to CloudFormation then as a way to do that. Rarely do we get into situations where CloudFormation doesn't support it, and then you're looking at either Python scripts or then we but that doesn't just go for Amazon services. That goes for other services as well. So we looked at various VPN clients and some great products and stuff that are out there. But if I can't interact with it at an API level and I can't interact with it in code, then as an organization, we kind of have to ask ourselves, okay, we have 90% or 95% of what we do is in code, but this 5% or this 10% or whatever it is manual. Is that acceptable? And that's a conversation that organizations have to have. Some organizations are comfortable with that. Some organizations are comfortable with, okay, you know what, 10% of this is going to require some manual intervention. Other organizations are not. They're bought in on that infrastructure as code and that really configuration as code mentality. And they're like, no, if I can't manipulate that in code through pipelines or through that process that I've established, we really need to find a different solution or find a different way to accomplish that. And so it just kind of depends. I don't know if that answers your question. That's kind of rambling a little bit. The answer is yes, but it's a good question. It's a very good question, and it's one that we encounter not a lot, but we do encounter it, especially as newer tools and newer things come out. So, any to that? I think it was Adam.
But you are, Eric, able to combine the CloudFormation at whatever augment the Terraform with the CloudFormation if needed.
Oh, absolutely. There was this honestly, this is one of those things. So there's a great auto scaling groups to this day. There is I think it's the update policy is not accessible via the API. It's accessible in CloudFormation, but it's not accessible via the API. So you can't even do it with a Python API, and therefore it's not available because it's not an API. It's not available from Terraform. And so to this day, one of the best ways to manage an auto scaling group inside of Terraform is to actually utilize some CloudFormation to build out and manage that CloudFormation stack inside of Terraform. And so, and I believe I have an example in the code we can look at here, but CloudFormation is what manages the auto scaling group, and then Terraform is managing then the CloudFormation stack and building that out and managing that process. And so there's definitely areas within within cloud deployments that we're going to use whatever tool makes the most sense in order for us to be able to push that out there. So.
Great.
All right, moving on. So CI/CD, so continuous integration, continuous deployment, right? So a lot of organizations, most organizations we interact with anymore are very familiar with this at a high level. And it's basically, we're taking code from the developer, we're going to run our set of tests, we're going to scan for vulnerabilities, more tests, integration tests, performance tests, the whole bunch of different types of testing that we're going to put on it. And then we're going to deploy it out to production, and we're going to repeat that. But most organizations that we interact with at this point treat their infrastructure and treat their production environments and their dev and their test environments very differently. And so you've got your development teams, whether it's JavaScript or Java or Golang or whatever languages that they're using, and they've spent a tremendous amount of effort sort of putting this pipeline and putting this process in place to be able to take software off of their laptops and go do amazing things with it and get it ready to deploy to production. And then you'll go look at the infrastructure teams, and the infrastructure teams are still kind of figuring that out, or still looking at whether or not that's a good thing. And so one of the questions that we like to ask when we encounter those types of organizations is, why are you treating your infrastructure any differently? Why is why are you not treating that as that code and running that through that CI/CD? Obvious questions we get. Wait a minute, you're going to deploy those infrastructure automatically? Are you nuts? Are you going to, you're saying every time somebody commits something to Git, it's going to roll out to prod? And depending on how comfortable you are, answer that be yes, absolutely. So most of the places that I've worked with that get to this level, it's a process to get there, right? So what we end up with, more often than not, is we'll end up with a very active development environment, very active test, and even pre-production environments. But when they get to production, we still get that sort of that stop sign that says, hold on. Now, I don't really have anything wrong. I don't have an issue with the stop sign and the manual validation and check. I think that's very prudent. And unless you're really, really confident in your tests, I think that's a positive thing. However, when it comes to actually deploying that thing, that code or pushing that, making that final push out into production, I still heavily advocate for doing that in an automated way. And so while Jenkins may have a pause, or Concourse or Circle CI or whatever tool you're using may have a manual check before it actually rolls to production, I still want to utilize all of those tools to manage that production environment. So a lot, I mentioned them already, like some of those common tools, the Jenkins, Concourse, Circle CI. Amazon themselves has a great suite of tools that continue to build out. And we kind of have a little bit of fun with the AWS code build and code deploying code pipeline, because I will write those in Terraform. And so you get the fun of the chicken and the egg of, I'm managing all of my pipelines in Terraform, but I have to deploy my Terraform to get to my pipelines. And so you get some of that fun stuff. But yeah, there's lots and lots of great tools out there. So the tool choice, in my opinion, isn't really critical. Each have some positives, each have some negatives. The biggest thing for me is making sure that's done in code, and that it's checked into Git, and it's something that you utilize from laptop all the way out to that production environment. And something else. So right? So Jenkins, we've all, I would imagine if you've ever worked with Jenkins, you've encountered the Jenkins server that nobody touches, that has probably 1,000 jobs, and they're all manually created, and we don't touch them, and we don't ever edit them. We just copy them and we make a change to it because we don't want to change the original one. We've all been through those Jenkins environments, and those are another those are a thing of the past as well, right? So with configuration as code, with build pipelines as code. When you look at Concourse and all of that stuff, Concourse ones being built in YAML, and even with code deploy and code build and code pipeline, being able to do that type of stuff in Terraform, there's really no reason why all of those orchestration jobs shouldn't be in code as well. And so being able to, again, everything in code all the time, and giving you that opportunity to be able to recreate that, to be able to build out, test, is super, super critical. So to be able to really take advantage of the ephemeral nature of the cloud. So.
Yeah, I think a lot of times, infrastructure folks, and then database people think a lot of times at places they get a pass on. I mean, I'm not a developer. I don't have to put my stuff in source control and things like that. I mean, but I think we've all seen the maturation of that, and the how that's progressed. And I remember I was at a client the one time where the people from a company called ZB Labs, they have a product called Excel release that we were looking at and deploying. The sales rep came in, and we were sitting with the teams of the DBAs, and the sales rep from ZB Labs said, so you guys got your database scripts, you got those in source control somewhere, right? And the DBAs all looking at me, well, no. And I was blown away the fact that the I'll say it again, the sales rep was just aghast that the database scripts were not in source code. And I mean, he's seen enough of it, he got it, that that's just something we're getting to. And so I think it's a mindset for the entire organization, for everyone, that it's I guess that's why we have this whole DevOps thing, which again, another word that I basically hate anymore. But it's the whole idea that it is all code, and it can be all code. It's a mind bend for a lot of people, but you can get there, and then makes it a lot easier to get everyone on board. So. And by the way, I think Eric's having, you might think Eric is having some connection problems, but no, that's actually his voice. He's part cyborg. So, it's just, you get used to it after a while. Proceed, Eric.
There is a question.
Nope. Question from Jack. What is your opinion? Is YAML JSON really infra as code, or just specification languages run by interpreters you have little control over? That's another good question. I'm sure there are some folks that know Ansible that immediately have taken issue with what you said. So my opinion, Terraform is really just HCL. So it's just YAML in another form, right? Or it's just a super special JSON. So in code for me is going to be anything that I can check into a Git repository and really manage with a text editor. So if you really, really want to take it all the way back, if I can edit with Vim, then it works for me. And so when I look at things like Chef, Ansible, Terraform, really any of those types of things that have got a language that you're going to write in, that to me is infrastructure as code. It's either going to be that configuration management, or it's going to be the infrastructure itself. And so I guess whether it's, in my opinion, whether it's on YAML, HCL, a straight Python script, Ruby if you're really crazy, there's an opinion for you. But there's all sorts of different things that you can do that. And to me, the end goal is if I can edit it with Vim, then we're good, and I'm good with it. So I don't know. Levis, what's your opinion of that?
Yeah, I go along the same vein of just the fact that it's, I guess, yeah, if you look at code, okay, it's not a code. It's maybe not Python or Java or whatever, but it's the main point is that it's in, I would say, the crux of it is it in source control? Can it be, can it be tracked, edited, and then of course, the fact that it does then get executed, whether it's YAML or whatever the format of it is, as long as it can be automated and source controlled and deployed, then that's what really is what we need to focus on. I mean, yeah, it's not code, I guess, but more so it's there and it's the single source of truth. So, Jack, what are your thoughts?
Yeah, I struggle with this too, because I tell everybody to use CloudFormation, use some sort of scripted thing to make sure that they check that into the repository, and make sure they execute it with CI/CD. But more and more as the tools get more specialized, it becomes harder and harder to justify it as, oh yeah, this is code that we can verify locally, we can do lint checks on and everything like that. CloudFormation, somebody was talking about earlier about how Terraform can integrate with CloudFormation when it doesn't have the capability to do so, do some task. CloudFormation also has solutions for that, and they involve creating a custom Lambda to execute some internal API that Amazon hasn't exposed versus just configuring it in your code base, right? With custom resources. I feel like it's hard to explain the difference between configuration as code in CI and actual code that you have written to manage your infrastructure to people who have been like old school ops guys that have their own custom scripts and things like that at large organizations. So I agree with you guys. You have to check it in. You have to get in through CI and CD. It doesn't necessarily mean that you have test driven the whole thing, which I get that argument too a lot of times. So I was just interested in your opinion on the matter as well.
Yep. No, and I think that's great. And you're absolutely right on the CloudFormation with those custom resources. There's definitely a lot of times where, especially when Lambda came out, I was a big proponent of Lambda all the things, and utilizing those custom resources to be able to do stuff with Lambda. I freely admit there were a couple of times I did some things and I was like, wow, I probably shouldn't have put all that in there. That just made that a mess. But yeah, for sure. Now the one thing, so you bring up test-driven infrastructure, and I would definitely say that there's test-driven in the purest of sense, and this would actually probably be a whole other hour-long topic. It would be great to get into that. But test-driven in the purest of sense is getting better and better with things like spec testing on the AWS resource side. We're doing some projects right now with OPA to actually be able to do some validation of Terraform plans prior to actually executing those things. And so a lot of those tools and a lot of those frameworks are really growing and are very, very exciting from a test perspective. But at the end of the day, a lot of times you have to build it before you can run the test to validate that it's there. Though, again, tools like LocalStack is certainly much more mature than it was, even really a year ago, to be able to use in a local testing environment. So there's lots of, like I said, that'd be a great topic, honestly, for another day is doing really test-driven infrastructure, how to take your infrastructure code, to your point, and actually validate prior to doing anything, stupid in a production environment. So.
And I think, Jack, just as far as it should be, yeah, could you go along and say, oh, we're a test-driven shop, so if you're doing code, all code has to be test-driven. So if your infrastructure isn't test-driven, I think they're getting a little heavy-handed with that, right? It's let's try to progress in with good faith, in all good faith, and if we can test drive areas of the infrastructure, let's do it. Let's mature that, but let's make sure we're also just progressing towards auditable, repeatable, dependable infrastructure and things like that. So.
Yeah, and for those that are not aware, Jack also posted something in the chat for a tool called Modo. So for mocking out AWS services. Let's see. All right, so let's look at a couple of diagrams. So these are the diagrams for both the master and then the sort of the sub accounts. And so when we started building this process out, started off with essentially the fee account structure. So we had a master account and then two sub accounts. One was a development environment or development account, and the other was a production account. And so we utilized really account level separation to help manage some of the identity and access management. You can do lots of amazing things with IAM, as I'm sure a lot of you have experienced. But the more amazing it gets, sometimes the more difficult it gets to maintain it long term. And so sometimes it's just easier to have a separate account and manage your permissions and structure in a separate account. It just makes it a little easier to figure that out and to maintain it long term. We ended up with a master account. So our master account had a transit VPC in it. So we're utilizing a AWS Transit Gateway inside of US East 2 in this case. Had a transit VPC. The transit VPC really doesn't have a lot in it other than, in this case, had an internet gateway, and was where the client VPN terminated. We also utilized Amazon Route 53 resolvers, which if you haven't used before, especially in a large transit gateway network, Route 53 resolvers from a VPN perspective are fantastic. They really help solve a lot of DNS issues across multiple accounts and multiple environments, and do that in a very, very efficient way. And then actually inside of that master account, and still inside of US East 2, hooked up a small tools, essentially a tools VPC, and ended up actually with a couple. We had a sort of a development tools VPC and then a production tools VPC with a Jenkins ECS cluster. Artifactory lived there. Lots of different essentially development tools, GitHub, some other things lived inside of that VPC, and utilized the transit gateway in that as an internet gateway access point. So it was really just that private subnets with some services hosted in them, and then again stamping those out as we needed for various environments. Obviously, inside of the master account, we utilized it for AWS organizations, and had some pretty extensive AWS identity access management stuff was configured in there, different roles and policies. AWS config, AWS CloudTrail. Obviously a lot of the sort of the standard layout of an AWS account. And then in the sub accounts, so everything again would roll back through that transit gateway. So we would essentially stamp out product VPCs, which had a set of subnets, both a public and a private set of subnets, and then routing rules to allow access over that transit gateway back to the private VPCs. But again, obviously routing rules and the internet public subnets inside of that VPC, and then would actually be able to do these and roll these out into multiple regions. And so you'll notice that the VPCs themselves, those product VPCs, were identical. And so again, that's a set of Terraform modules that would sort of build and deploy that. Used AWS Key Management Service, Secrets Manager, a lot of S3 buckets. Again, pretty much the standard. From a services perspective, didn't really do anything fantastic and amazing. Just really utilizing the standard set of Amazon services to provide a platform, in this case for a Node.js application running with a Mongo database backend. So the big goals again that we had were we wanted to make sure that we could look at that. Let me see if I can put it here. So our AWS client VPN obviously resolving here. So this is where all of our clients would come into that, and essentially into that transit VPC. And then we were able to make sure that we could manage access to different resources appropriately. And so segmenting things out, if I was a developer, I would have access to, the 10.2 set of that IP space, be able to access the development Jenkins, be able to access the sandbox Jenkins, Artifactory, those types of things. But then obviously segment out the production access would be a different client VPN user set, and they had routes to the appropriate production networks. By utilizing that transit gateway, we're able to then extend that same VPN network out to then multiple accounts, multiple regions. And then as we would stand up new VPCs or new dynamic environments for testing or for whatever what was something that was, hey, I've got bug 687 and I want to go test to validate that I got that finished, I can stand up a VPC, deploy the product to it, test that bug if I need to, and then tear that down, but still be able to access all of the resources dynamically and hook those things up appropriately to the VPN. So all of that stuff, really put together and built out with Terraform. So that was the goal. That was what we ended up building. And so actually diving in and starting to build through some of those things. So Terraform itself, right? So there's the CLI, Terraform Cloud, Terraform Enterprise. We ended up opting for CLI. Terraform Cloud was still very much in its infancy when we started this project. And Terraform Enterprise, for this particular client, was just not the regular Terraform CLI. Pinned, we pinned our version. So why would you pin the version? So obviously with Terraform, if I'm running 12.12 and somebody somewhere along the way, and that's what I've got installed on Jenkins and it's doing its thing, and then somebody somewhere installs 12.13 and they run a Terraform apply, that state file then will only allow 12.13 or above to be able to manipulate that state file. And so we want to make sure that we pin our Terraform versions with what is on our Jenkins instance, in this case with Jenkins, but our CI/CD, just to kind of keep things going, and then breaking things up in terms of source code management. So Terraform modules themselves, there's the single repository or multiple repositories. That is, I think that's just sort of an opinionated thing. I'm a fan when it's the modules. I like a single repository because I can just have all of my modules in a single place and be able to manage it. A lot of people prefer the multiple repositories. I don't really have a strong enough opinion in either direction to really, I guess, advocate for one or the other. It's just kind of whatever works for the team. And then in this particular case, I put together sort of core Terraform code. So it would manage the master account, sub account, the transit VPCs. And so that core Terraform code sort of lived in its own repository, utilizing Terraform modules, but was sort of separate out from any of the platform code or any of the data platform stuff. State files. So we talked a little bit about this earlier, but this is really sort of the crown jewels. This is where all of the configuration, configuration for your cloud environments is stored. There's lots of different options. Don't ever local storage ever for anything that's going to go into a production environment. Again, security. So in this case, we were utilizing an S3 bucket. So making sure that the S3 bucket had versioning enabled, logging was enabled. We had specific bucket policies that dictated who was allowed to access that S3 bucket. For the way that we did it, essentially had an S3 bucket inside of the master account that managed all of the Terraform state files for all of the accounts within the corporate infrastructure. So we sort of had one spot for all of our S3. So we didn't have state files sort of scattered all over the various accounts. Everything rolled up into that single master account. And then I can't speak highly enough about import and being able to import those, in this particular resources and we had a couple of situations where a developer in their own, would be given access, would go build something to see if it would work. And while it's not my particular personal preference to build things by hand and then come back, sometimes organizations, it's lots of different people, lots of different opinions. And so in this case, we had a couple of situations where we had some folks that were given permission to go and build some things. And so we were able to take those. see what they had built and write Terraform around it and import that stuff back in and actually then build and maintain and move that stuff forward. And so, again, my preference, we start with code, we end with code, we're always in code. Organizations are lots of different opinions. And so being able to be flexible with some of that and be able to allow folks to be able to have some say and some movement in that is definitely important. So workspaces. So Terraform is really the key way that a lot of this was able to do. We were able to do a lot of this. It really maximizes the amount of code that we're able to reuse. In terms of how we sort of put our infrastructure together. So we've got, we can utilize the workspace name and how we build these things out. So I've got an example here of a set of locals variables. And so if we've got a VPC name or a transit gateway name, if we're in the default workspace, then it's going to be one thing. Otherwise, it's going to be transit workspace. And so if I wanted to build out a dev environment or a test environment, or wanted to build something out that way, I could actually build out and just create a new workspace within Terraform, use the exact same code, and then based on the way that I've written my HCL, all of the naming and all of the namespaces, we shouldn't have anything that would overlap, right? So if I'm in my default space, everything's going to be transit or TGW. But if I want to build a demo, I'm going to just create a demo workspace inside of the Terraform, utilize that same code, and then the Terraform workspace and the locals variables will then will take locals variables and data sources will then take care of making sure that things were named appropriately. The other thing wanted to call out here as well is being able to specify that workspace inside of a tag, in addition to owners and other things, making sure that your resources are appropriately tagged and making that consistent across all of the things that you're deploying and all of the things that you're building is as I'm sure a lot of you already know, is definitely it's extremely important. And so being able to put that into code, be able to manage that inside of a workspace so that I can very quickly look at a resource. If it doesn't have a name, like an EC2 instance, EC2 instance, I guess it's got the name as the tag, but I can look and see what workspace it's associated with and be able to identify that very quickly. Providers. So providers is really in one of the most powerful things that Terraform allows you to do. And so in this case, we're going to look at Terraform. It's managing all of your API interactions, and there's a ton of different providers and a ton of different things that are out there and available today. And they're actually not that difficult to write if you so choose, right? So anytime you take on the process of writing code, that's definitely a conversation at an organizational level to say, hey, we're going to write this. It's going to take us X amount of time, but then we have to make sure that we're able and we're capable of maintaining it over a long period of time. So it's not something that I would say you undertake lightly. I don't think you just wake up tomorrow and say, you know what, I'm going to write me a new provider for AWS. But if there are definitely situations where it would make the organization product that we want to interact with at an API level and has an API available, it might make sense for that organization to write a Terraform provider to interact with it so they can continue to do that. And building that out is not difficult. And there are a number of different examples to do that. But as an example here, right? So within for AWS itself, Terraform provides the ability to use aliases. And so I can have a region as US East 2, that's going to be my default provider. So if I don't specify in my Terraform code which provider to use, I'm going to go use AWS and US East 2, but I can alias them. So I can say, hey, US East 1, so I can specify it in my resource code that, hey, this needs to go to US East 1, or this needs to go to US West 2, et cetera, et cetera. Again, within Terraform, within those providers, we can assume different roles. And so when we talk about multiple accounts, this is where, again, workspace and roles, variables and workspaces can become super useful to be able to do this, again, in an automated way to say, hey, I'm in the dev workspace, or I'm in the this particular account, and I'm connecting using this particular role, and I can go ahead and assume that role in another account. And then I've got a couple of examples. We were doing some stuff with Kafka, so being able to use a Terraform Kafka provider and actually be able to set up topics and configure those in Terraform, again, right next to all of the rest of our infrastructure inside of HCL, inside of our Terraform was super critical. And then again, you can also intermix those with Google. So I can have my AWS code, my Google code sitting side by side. Talk a little bit about modules. So we've got our, obviously we're going to create an IAM account alias module. Modules, different people have different opinions. I go back and forth. I used to be very much, if there was a resource, I would wrap it in module code. Now I tend to look at modules as sort of groups of resources. But I still very very heavily rely on modules to be able to do the work that I want to do. And so, like I said, it kind of goes both ways sometimes. Whether it's for every resource, I want to put a module together that has either default variables or default tags that would get associated with that particular resource. Those types of situations are definitely important if an organization has those types of requirements. So, for example, if we were looking at an S3 bucket and every S3 bucket needs to have this particular tag or this particular information, I can make that a required variable in order to be able to use that module. That, all right, I have to supply that particular tag information in order to use that module. And I can do an analysis of the Terraform very quickly to see if somebody is using resource AWS S3 bucket. And if they are, I can flag that and immediately say, hey, you need to get that fixed. We need to utilize this module over here. Versioning modules is really useful, and would definitely encourage everybody to utilize version modules for whatever work that they're doing. That just kind of helps future proof things as you're moving forward, so that you kind of have a snapshot in time of this is what I was doing. Again, it also then makes it very easy for you to go back and say, okay, we had a bug in version 3. I need to make sure everybody is at least at version 6. And I can do a grep if I need to on the command line to see, all right, who's using this particular module at version 2 and make the changes that I need to make moving that forward. So, so this would be an example of a multi-purpose module. So this is an AWS. So we've got some of the basics established here. So we've got our name for the bucket, the ACL that we're going to utilize, region, whether or not we're going to force the destroy. And then we kind of go through and we create just some different, so we always want server-side encryption, so we need to make sure that stuff is there. And then dynamic, so sometimes you need logging. There are logging buckets for logging buckets, or you can get into some loops there. So we'll take a look, and this can be sort of a conditional thing. So instead of always having to set up logging, I can still use that same module. And then again, I can audit then the source code to make sure that I know which buckets are using that. The same thing for lifecycle rules. And then we can add additional resources inside of this module. So this module actually contains 2 different resources. It's the S3 bucket itself, and then the actual public access block for that particular bucket. I think we're very much nearing the end. So I guess we'll skip ahead to questions and see if anybody's got any questions right now. Going once. Well, Brian, I think we'll turn it back over to you, sir.
All righty. Thanks for everybody. Thanks for attending. Thanks, Trility, for hosting. That was awesome. It was great to get everybody together again. As Rhonda said, we'll send out a survey and a copy of the slides recording afterwards. I'll get that done soon. So if there are any other topics anybody else would like to talk about this year, whenever, let us know. And it's always open to suggestions for what we do next. So with that, everybody's probably got 1 o'clock calls, so I'll jump off. Thank you.
Thanks,
Thanks,
guys.
everyone.